Alright, so now it's being recorded. Okay, so I did not even know I'm gonna do this. I'm not even TA in this course, but we'll do a review so that you'll have more time to study for 102 basically. Before we do go over function, I wanna do some high score review. You know, if you're given, let's say 2 points. So let's say given P1, let's call it X1, Y1. Okay, and they give you another point, P2. Let's call it X2, Y2. Okay, then the line passing through those 2 points passing through the 2 points, how do you represent it? Anyone? That's the slope, you're correct. But what is the line though? Okay, so first of all, we need to know the slope, that's correct. Okay, so you should know when they ask for a line or like a straight line, you should know 2 things. One is the slope, right? The slope of the line. And you should know at least 1 point, right? And one of you mentioned the slope, let's call it M, is rise over run, which is y2 minus y1 over x2 minus x1. That is correct. So if we know M, and one of you mentioned y equals to mx plus b, okay, so that's one of the form. This form might be the form you're more familiar with in high school. So the form you mentioned is called slope-intercept form. Intercept form. Okay, so this is the one you guys are more familiar with, which is y equals to mx plus b. Right, everyone's familiar with this. So to find this, you also need to find b. Right, you also need to find what b is by solving the equations. So you would need to plug those two inside and find b. That's one way. What about do you guys know the other form of equation of a line? Let's say nice. Okay, so the other form is point slope form. Point slope form. Okay, so in this form, you can get to the equation directly if you know the slope and 1 point, which is y minus y, let's say y0 or y1, doesn't matter. So it's like a point. Let's use y1 here. Equals to m times x minus x1. Okay, so this one, the second one is what we use more frequently, so more frequently in university. In calculus or in calculus. Yes, in 102 we will use this more. All right, but other than this, another thing I want to mention is, what about parallel line? If you have a line that's parallel to a line, then what do we know about it? Anyone remember? The slope is the same, that's correct. Okay. So if they say two vertical, let's say 2 lines are parallel. That means they have the same slope. Okay. Same slope. What about 2 lines are perpendicular? Then what's gonna happen? They are not just reciprocal. That's correct. Not just reciprocal, it's a negative reciprocal. Okay? So 2 lines are perpendicular. that means that their slope, so let's call the two lines slope m1 and m2, then the product should be -1. Okay, so those part are just like high school review. I suppose everyone know already, but just in case you did not know, you should know this. Okay, this is just high school review before the actual university stuff starts. Okay. More than not just this, the other thing you should review is absolute value. But since you guys been doing absolute value in 102, and everyone here is taking 102, I'm not gonna do that. Maybe I'll do a little bit when we get to limits, because first we're not even on limits yet. So when we get to limits, I'll do a little bit of review. It's a good review for 102 as well, so maybe I'll spend more time there. Because you guys know 102, we care about absolute value. This is part of the reason I'm doing the review for 135 now, because there are some overlap between 135 and 102. For example, the first part we're talking about here, function. You guys will be testing on image, right? Find image and prove image. This part is 102 material as well. So let's first look at what is the function. You guys should know what is the function, so that's part I'm not gonna do it. So the one that they usually test you about is the domain of the function. So we call it the natural domain of the function. So in calculus, the domain is not gonna be given to you. You are not gonna see something like f mapping from A to B. In 102, A is just your domain. But in calculus, they only care about the natural domain, so it's the biggest set that your x can take values from. So the set D here, this is what you will be tested. And it will be tested in 135. They'll give you a function, and they ask you, what is the domain of this function? So what do we do in this case? They might ask you to find a range, but that's not the main point. Most likely you will be tested in domain instead of range, but range we'll talk about that in a moment. Don't worry, we'll get there. But domain in 135 is more important. Okay? So in 135, this is more important. In 102, this is more important. But if they give you a function, what do you need to check to find the domain of the function? Let's just say like a general function. Do you guys have any opinion, any tips on how to find the domain of the function? So what can make your x cannot pick certain value? Consider restrictions. Like what kind of restrictions? Denominator 0, that's one of them, that's correct. Okay, so one of you mentioned you should check the denominator, so denominator cannot be 0. If you have a denominator, you want to make sure it cannot be 0. Anything else? Square root, that's correct. Okay, so let's say under, not just square root, under even root. Okay, so this part under even roots, this part has to be greater than or equal to 0. Anything else? The argument of log must be greater than 0. That's correct. Okay, that's another one. So if you have log something or log something, this part has to be strictly greater than 0. Anything else? Can you come up with anything else? What about trig functions? Those are for general functions, right? But if we have trigonometric functions, Would that affect our domain and range? Yes. For example, which one specifically? Have infinite domain, not infinite domain. Well, yes, you are right. Tangent, right? So the few that you need to be more careful. One is tangent. There are some. So let's write it here. So you need to be careful with tangent. There are some. Oops, that's tax. Tangent x, right? You need to be careful. There are some values you cannot pick. And the other one is, you guys are correct, inverse trig. Specifically, the one that's being most tested is arctangent. Okay, so arctangent, you 100% need to know. What do you need to know? The graph of it. Okay, so anyone want to describe what the graph of arctangent look like? So how do we know? We will test those, right? You test those. We'll see examples in a moment, but what is arctangent? For tangent, there are many values you cannot pick, right? So you can go here, but there is a vertical asymptote here, there is a vertical asymptote here, and you can go here, and you have vertical asymptote here, and then you can go here, and you have vertical asymptote here. So those vertical asymptotes are the ones you cannot pick, right? Domain is negative infinity, range is negative power 2 to power 2. That's correct. Okay, so those, the graph of tangent x, the graph of arctan x. Well, let me draw it here. You should know what they look like. What are the domain and range of those? Those are like always being tested. So like this. Okay, and the other ones are basically those three: denominator, under square root, and log functions. Don't all trig functions? Well, I just gave you a counterexample. Tangent x. There are many values you cannot pick. Okay, so there are some you need to be more careful with, and that's about domain. And for range, you guys should know how to find range, right? By now, in 102, you should know how to find the range of a function. Yeah. It's basically image. Okay, so in 102, it's basically image. We're only talking about one variable. It's not as bad as 102. We have multiple variables. So this, do you guys need me to go over? How do you find the rangeable function? Maybe I'll quickly go over. So in calculus, there are many ways. In calculus, you can always use inequality, just like how we are doing. So let's say it's like image where the codomain. So in calculus, they don't talk about codomain. They don't really talk about codomain. So just domain and image. There are many ways. First, you can always use inequality if you want to. Inequality is basically mixed with function transformation. You guys remember function transformation? So for example, if you're shifting the graph out by 2 points, by 2 units, or down by 2 units, then your range would go up or down by 2 units, just like that. So inequality is mainly associated with function transformation. Another way in 135 is if the function has inverse, if f has inverse, then the domain of inverse is the range of the original function. Okay, that's another way. So if you have inverse, by definition, and you know that, well, the domain of the inverse would be the range of the function. Another way is you can take limits. So for example, if you know the function itself is strictly increasing or strictly decreasing, right? Then you can take limits and see where can the function go. So let's say take x goes to infinity, take it goes to negative infinity. So that can give you some idea of where the bound is. What's the best way? There is no one general way that works for all functions. It's just impossible. It's impossible. There's no specific way that actually works for all different functions. I wish I can tell you there is one, but unfortunately that's not true. Especially in 102, when you have like multiple variables, it's impossible to do it in one specific way. Sometimes you just need to give it a try or something like that. Like, plug in some values and give it a try. That's another way. It's not the best way, but it's one way. So it really depends. But the functions you've seen in 135, okay, in 135, the functions you see, a lot of them can be solved using function transformations. A lot of them. Okay, so if you find like your specific, let's say like the ones they ask you what is a range, otherwise they might not even ask you. Like something like this, they might not even ask you what is the range of the function. So if they ask you, most likely it can be solved using function transformation. So if you start with like the parent function, you shift it, you scale it in some way, and then you can get to the final function. That can tell you the range of the function. So let's do domain instead, because this is more important in 135. All right, so what is the domain of A? Give me your final answer and we'll take it out together. Final answer is what? Negative infinity to negative 2, union 5 to infinity. For A, 0 to 5, negative 2. Wow. You guys all got different answer? So far, only one of you is correct. This does not look good, guys. Now I'm even worried about your 135 test. 0 to 3 is the correct answer. Okay. Wow. 0 to 3, this is correct answer. Guys, what's going on? Now I'm even worried about your 135 test. Okay, let's compare answer for B and C first, and I'll take them out later, okay? B, what is your final answer for B? B, are you too scared to talk now? This is domain. B is what? Domain is negative 1 to 0 union. Oh no. Okay, you guys have completely different answer again. One of you is correct. Anyone else want to share your? I'm really worried now. Okay, two of you are correct. The correct answer is, oops. The correct answer is negative 1 to 0, union 0 to 4, union 4 to infinity. Okay, this is the correct answer. What about C? What is your final answer for C? Okay, I received one answer. Anyone else? And Dion, what is the domain for C? Nobody? Are you too scared? No. Negative infinity to 3 is incorrect. Not equal to 2 is also incorrect. 1 to 2 union to 3 is correct. Okay. Okay, this does not look good, so let's take them all out together. I was hoping you guys were doing well so I can skip some of them. Now it looks like I cannot skip anything. So let's talk about A. This is bad, guys. You need to study harder. Domain. So what are the restrictions I have for it? So 3 things, okay? First, you check, is there a trig? No trig anywhere, no trigonometric function anywhere. So there are only 3 things you need to check. Denominator cannot be 0. So let's write that down. Denominator cannot be 0. So square root of 15x minus 3x squared cannot be 0. That's the first restriction, right? And second restriction, we know inside of the square root has to be greater than or equal to 0. So let's write that down as well. And the third restriction is long inside of long has to be bigger than 0. So that's x minus x squared plus 6 has to be greater than 0. Those three restrictions. Okay. How many of you got the three restrictions correct, at least? If you got the three restrictions correct, type something in the chat. Okay, so seems like this part is okay, but those questions are usually multiple choice questions, so getting this correct is not, it doesn't mean anything, guys. Really doesn't mean anything. It's gonna be a multiple choice question, usually. Okay, so combine the first one and the second one, we know that inside cannot be 0 anymore, because if this part is 0, the whole thing will be 0. So combine those two together, we know that 15x minus 3x squared has to be strictly greater than 0, which means 3x times 5 minus x has to be greater than 0. Okay, this is an inequality. Remember how we solve it? I said we can draw a real number line, right? And we can put the values, make it 0 on the real number line. So we can put 3 here. The other one is 5. When x equals to 3 or x equals to 5, we have 0. Now we can plug in values to check if they're positive or negative. So let's say put in 0, which is less than 3. You have a negative number. Plug in 4, you have a positive number. Plug in, let's say 10, you have a negative number. Okay, so for the whole expression to be bigger than 0, we have x has to be in between 3 and 5, not including them. Does this part make sense? When x, oh sorry, not 3, what am I talking about? 0. Oh my god, 0, my bad. 0 and 5, okay, 0. Okay, so any question for the first part? This is what we got for the first two equations. That x has to be between 0 and 5. So far, so good? Okay, so now let's look at the last equation. So look at this equation. So now it's a quadratic equation, right? And I can factor it out, right? So I can have negative x squared minus x minus 6 is greater than 0. Factor it out, I have x minus 3 times x plus 2 is greater than 0. Okay, and just like here, you can draw another real number line and put the values on top. So when x equals to negative 2 or x equals to 3, the whole expression equals to 0. And then you can plug values in and check the sign again. So when x is, let's say, negative 5, you plug it in, negative, negative, negative. So 3 negative will give you negative. When x is, let's say, 0, you have a positive number. When x is bigger than 3, for example, 5, you have a negative number. So for the whole expression to be greater than 0, we pick in between those two numbers. So from this expression, we have x is in between negative 2 to 3. Are you guys okay with this part? The last equation? Right? This is good. Okay, so now we have two things. And remember, they both have to satisfy at the same time. Right? So you have the intersection of those two. Well, You guys know intersection 102, right? So what is the intersection? If you don't remember, you can also draw it on a real number line. So you can draw both on your real number line. Let's say 0 here, 3 here, 5 here. Or you can draw them both, and you'll see. If you don't know how to do it, you should, because this is 102 stuff. If you don't, draw the real number line so it's really clear for you. Okay, so if you draw them both, you'll see that, well, this part is the only intersection part. Okay, so combined together, your final answer should be from 0 to 3. So the domain is 0 to 3. Okay, and this is our final answer. Question? Is this clear? So where did you make the mistake? We saw so many incorrect answers. But if that makes the expression positive, what do you mean make the expression positive? What are you talking about? Here? Yeah, it makes the expression positive. We want it to be positive, right? Yes. We took account of this negative sign. When I do those, I multiply by negative already. You could, but that's gonna change this to negative. So everything's gonna change. Okay. You could remove this, but if you remove this, then the sign is gonna change to -0. I mean, smaller than 0. Okay. This makes sense? Move on. B. I'm not sure where you made the mistake. It seems like everyone know what's going on, but at the same time, you cannot get the correct answer. That's pretty bad because if it's a multiple choice question, even if you know how to do those, you cannot get any partial marks. Combination for me. Well, you can just draw a real number line. You know, if it's hard for you, always draw a real number line. Draw it out and it will be clear for you. Okay, B. So what are the restrictions for B here? So again, check denominator, check square root, check log functions. Okay, so after you do all the checking, you should have 3 restrictions because you have 2 different denominators. So denominator cannot be 0, so 4 minus x cannot be 0, x cannot be 0, and x plus 1 has to be bigger than or equal to 0. Right? Okay? And the first 2 will give me x cannot be 4, cannot be 0 either. And the last one is saying x has to be bigger than or equal to -1. So again, you can combine them together by drawing a real number line. So we have -1, 0, and 4. So remove 0, remove 4, and it has to be bigger than or equal to this. Okay, so if you draw this out, you'll see that, well, this is a union of 3 different intervals, right? So that's the final answer. So domain is -1 to 0. We want to include -1. -1 to 0, union 0 to 4, union 4 to infinity. Make sense? Is this clear? For the mistakes you guys make, you should not erase your mistake, okay? Because that's where you learn from your mistake. So for those of you, if you got this wrong, don't erase it, leave it there. Okay, maybe circle it and you know, check it later, because that's how you can avoid your mistake. Me telling you what are the common mistakes people make is not gonna help you that much, but your own mistake is the thing that can help you yourself. So you know that in the future you want to avoid making the same mistake, because that's your how your brain works. Don't erase them, okay? Don't get rid of your mistake. Leave it there and learn from it. C, okay, let's do C. Again, is there a denominator? Yes, we have denominator, right? Do you guys see it? We have a denominator. Here, this cannot be 0, so x minus 2 cannot be 0. Now check, well, is there, for this, do you plug in values? Yes, that's all I did. I plug in value, like, for example, this one, right? I know it's interval here, interval here, interval here. Plug in value, let's say -3 here. Check if this expression is positive or negative. Number here, let's say 0. Plug in, see if it's negative or positive. Here, plug in a value, see if it's a positive or negative. Okay, continue. And we have a square root as well. So under square root has to be greater than or equal to 0. 4 over x minus 2 square minus 16 has to be greater than or equal to 0. We do not have log, we don't have trig, so that's everything you need to check. Okay, and the first inequality will give me x cannot be 2, which should be clear for everyone. The second one, you can move things around, right? So you can move things around. So move 16 to the other side. You have 4 over x minus 2 squared is bigger than or equal to 16. Can I square root both sides? Yes or no? Can I take square roots on both sides? Guys? Yeah? No? Yes, okay, because both sides are positive, right? Both sides are positive. Square root both sides. You need to be careful because the right side is not 16. It's, what's the right side? It's not 4. Is it 4? Is it 4 or is it not 4? That's what I'm asking. Is it plus or minus? It's absolutely 4. Okay, because actually I should write it in the other way. This is not very accurate. I should write it like this. Absolute value of this is square root or equal to 4. Okay, but it's easier to change this to plus or minus 4 when you do calculation. But this is the correct way because square root of something square is the absolute value of something. Okay, remember in 102? Recall. Square root of x squared is plus, not plus or minus, is absolute value of x. Okay, this part, don't forget, we use it in 135 as well. Okay, so you need to discuss cases. Okay, you need to discuss cases. So when it's positive, the first case, 4 over x minus 2 is greater than or equal to 4. Case 2, you have negative 4 over x minus 2 is greater than or equal to 4. You need to solve them, so I'll quickly solve them. Okay, quickly, really quick. So 4, by the way, guys, can I cross multiply or no? Can I multiply both sides by x minus 2? Why not? What's wrong with that? We don't know. Nice. Okay, that's why I like 1 or 2 people, because you guys should know more than other people. We cannot do that because we don't know if it's positive or negative. If you want to do that, you need to break it into 2 more cases again, which is kind of annoying. Okay, so I'm gonna move 4 to the other side, common denominator. I'm gonna have x minus 2, and top I'm gonna have 4 minus 4x plus 8 is greater than or equal to 0. And then this 4 plus a is going to be 12 minus 4x. So 12 minus 4x over x minus 2 is greater than or equal to 0. Then what do I do now? Something over another thing that's greater than or equal to 0. What do I do now? How do I check what values do I have? Anyone? You guys know? Find restriction on top and bottom. How exactly are you gonna find? With both numerator must be, yes, that's correct. Okay, if you divide two things, they are positive, then they must have the same sign. So top and bottom must have the same sign. Okay, so they are either both. Common denominator. So this 4 becomes 4 times x minus 2 over x minus 2. That's how I got it. All right, so a faster way, faster kind of cheating way is you do this. So I'm gonna, like here, I can factor out a 4, right? And I can divide it, but doesn't matter. So let me tell you a cheating way. Not really cheating, but it's faster. We can draw a real number line again. The values you put on the real number lines are one top is 0. One is my top going to be 0. When x equals to what? 3. Okay, so you put 3 on your real number line. At 3 it could be 0, so we want a 3. We don't want to remove it. And check when is bottom gonna be 0. When is bottom gonna be 0? 2. Okay, you put 2 on real number line as well, but you're gonna remove it because my x cannot be 2. Okay? And with those 2 points on the real number line, you can do the same thing. You can plug in value and check one as a positive and then one as a negative. Does that make sense? Okay, so if you check, you have plus, minus, plus. So that means your x should be in 2 to 3. And this is gonna be faster than checking the discussed cases. Because I think it might be multiple choice, so teaching you the cheating way is much faster. Okay, the other way. Again, we're gonna move 4 to the other side. Actually, I'm gonna move this to the other side because this is negative, right? So that's better. We don't want negative value. So x minus 2. This time you're gonna have 4 have less than 0. So 4 times, so 4x minus 8 plus 4 instead of negative 4, which is less or equal to 0. All I did is move this to the other side. I'll come to them later. Oh, bless you. the top, I'm gonna have 4x minus 4 over x minus 2, which is less or equal to 0. Isn't the other way? Oh, yeah. My bad. I wrote the wrong thing. It's negative plus minus. In my original notes, I shifted to 4x minus 12. Anyway, and now what value do I put on my real number line to do the check? 1 and 2. Which one do I include? Which one do I not include? Include 1, that's correct. 1. And not include 2 because 2 is in the denominator. Okay? And now you check it again. So you should check again. So for example, plug in -1, for example. Okay? If you do that, you'll see this is positive, this is negative, this is positive. So you want negative less or equal to 0. That means you want x to be 1 to 2. Okay? Remember, we're including the 1 here and 3 here because the original wants less or equal to. Okay? Less than or equal to. If they just want less than or strictly greater than, then you don't want to include 3 either. Because that's when it's going to be 0. And now, you combine them together. Okay, there is no intersection, so it's just union of them. So domain is down. The union of those two intervals. Domain is 1 to 2, union 2 to 3. That's the final answer. Make sense? It's more complicated than the other two because you have cases we need to discuss. Does this make sense? Yep, okay. Move on. Vertical line test. What is vertical line test for? To check what? Vertical line test is used to check if it's a function. That's correct. What about horizontal line test?
To check if it's one-to-one?
That's correct. Check if a function is one-to-one. So if it's one-to-one, it has the inverse. Function is one-to-one. This part, you will do it in 102 as well. In chapter 5, we'll talk about injectivity. Injective and one-to-one are the same thing. Okay. But it's gonna be different. You'll see that in 102 will tell you it's not just if it's injective, then it has the inverse. It's more complicated than that. This is mainly because calculus, they don't have codomain. Okay, so they basically suppose the image is a codomain. But anyway, symmetry, even odd functions. So this you 100% should know how to check them. But what I also want to ask is for even function, because we're talking about symmetry. So what is even function symmetric with respect to? With respect to y-axis, that's correct. So this is symmetric. Oops. Spelling is wrong. Symmetric with respect to y-axis. What about odd functions? Odd functions, they are symmetric with respect to the origin, that's correct. So symmetric with respect to origin. So if you know the graph already, checking that will be really simple. But if you don't know the graph, you have to do the computation, okay? So let's do example 2, but we spent like 15 minutes and we did 1 page, wow. Okay. Wanted to be much faster, otherwise it's impossible for me to finish it. So we'll do some of them, we'll check some of them. We're not gonna check all of them. Let's see which one I want to check. Let's do a trick one. So let's check B. Let's check E. Okay, let's check B, C, E, F. Check if they're even, odd, or neither. Determine if they're even or odd. Even or odd or neither. Okay, so since we're running out of time, we're gonna do it together. What exactly do I need to compute, guys? What do I need to compute? Input, okay, that's correct. G of negative x. Okay. So if you compute it, that's 2 cosine 2 pi x, which is gonna be negative 2 pi x. So change it to negative 2 pi x. All right, can I do something? Can I write it in a different way? What does this equal to? Is cosine function even or odd? Cosine function is it even or odd? It's even, that's correct. If it's even, what can I do with a negative sign in there? What does it equal to? Can I remove the negative sign and keep it the same? That's correct. Okay, it's the same as 2 cosine 2 pi x. Why? Because cosine function itself is even, so the whole thing is even, which is just g of x. And this is because cosine is even. Cosine function is even. So this one, to be honest, I wouldn't even compute it. I can tell directly it's an even function. It doesn't really matter. Okay. What about C? If you don't compute it, can you tell if it's even or odd? Anyone? Without doing any computation, is it even or odd?
Even,
It's even. Why?
because since it's squared, it'll still end up being the same thing. So it'll still be equal to h of x.
Okay. Not just square, there's an absolute
And the
value.
absolute value, and the absolute value will
Exactly,
still equal the
exactly.
same.
So this one, you don't even need to do any computation. It's even. Okay, because the square and absolute value, they don't care if it's negative or positive inside. They're gonna be the same thing, right? So it's also even. You don't even need to do any computation. What about E? E, we need to do some sort of computation, right? E, at least you should know what it is, right? E is what? What's my fx? First, let's find our f of x first. So f of x equals to what? It's g compose h of x. So g compose x cube, which is tangent x cube, right? Tangent x cube is it even or odd? Do you need to do computation? It's odd, right? It's odd because tangent x, the tangent function is odd. So you don't need, if it's a multiple choice question, you don't even need to do the computation. What about F? Anyone? What about F? Do you think you need to do computation? Don't guess, don't guess. So first of all, it's a bunch of arctangent composed together, right? So look at this one. Is arctangent x even or odd? Arctangent is odd, right? This is odd. This is odd. We draw the graph before. Remember, the graph look like this. There's a horizontal asymptote. This is odd. So when you have negative x, it's the same as x, right? It's the same, sorry, it's the same as negative over arctan x. And this negative can be taken out again because this is odd as well. So the negative will be here. And then this negative can be taken out again because this is odd. Okay? So eventually you'll just get negative over arctan x. So it's an odd function. The whole thing is odd. Okay, so without any computation, you should be able to figure it out as well. I want to go over some basic functions, the elementary functions. This part is important for both 135 and 102. So 102, we will do this again in chapter 5. I'll tell you, you need to know the following functions. You need to know their graph, you need to know their domain, their range. Whatever I'm drawing right now, it's the same in 102, okay? All the elementary functions I'm talking about right now, you need to know them for Math 102 as well. Just not at the moment, but later. Maybe at the not at the moment, but later, like chapter 5, you need to do them. So the first type of function you should know is polynomials. Okay, polynomials, either it's linear, quadratic, cubic, or to the power 4, to the power 5, you should know. So polynomials. Especially their graph, what is their domain? Do we have a restriction for polynomial? No, right? There's no restriction. Domain is just all the real numbers. So what you should know, at least you should know linear, right? What does a linear look like? It's a straight line. What does quadratic look like? What does cubic function look like? And specifically x to the power of even, they all look like this. X to the power of even number and x to the power of odd number, they all look the same way as well. They all look kind of like this. This is x to the power of odd functions. Okay? Graph, should know how to do them. The next one is rational functions. Rational functions? What does it look like? What is the domain of rational functions? Let's call it f of x equals to p of x over q of x. What is the domain? X equals to 0? Not necessarily.
Q of x can't be 0?
That's correct. Okay, domain is q of x cannot be 0. What are the px and qx? They're polynomials, okay? This is polynomial, this is another polynomial. Question. Always want to ask one of you. Just a simple question. You don't have to answer now, you can think about it yourself. Is a set of rational functions filled? Yes or no? Think about it yourself, okay? Power functions. So x to the power of a. kind of functions. Okay, those are power functions. One A is, let's say, a positive integer or like a natural number. And is a natural. What does the graph look like? It look like what?
They look exponential, I guess.
Exponential? No. Backward L. No, what are you guys talking about? A is, so it's just x to the power of 2, x to the power of 3, x to the power of 4. It's those. Okay, polynomials, exactly. What's so hard about that part? Just polynomials, okay? Those are just polynomials. So this is not what I want to talk about. I want to talk about, what about when x equals to 1 over n, where n is a natural number? What does the graph look like? Root, okay, but does it matter if n is even or odd? Do they all look the same? It matters, right? So even will look like square root. Okay, so square root function looks kind of like this. Okay, this is when it's even. When it's odd, it looks like cube root. Cube root doesn't care if your x is positive or not anymore. So it kind of, again, I'm really bad at drawing, but it kind of looks like this. Cube root. Okay, cube root. What about my a is -1? What does the graph look like? Rational? 1 over x. Yes, that's correct. It's 1 over x. So what does the graph look like? You should draw the graph yourself, okay? I hope you all know, but if not, you should know. For both 135 and 102, you should know what they look like. Okay, next we have exponential. So something like e to the power of x. You should care about a to the power of x, but what we really care about is e to the power of x. What does the graph look like? Anyone remember? What is the intersection point? Those are something you should know. Okay, this is one. And what's the inverse? What's the inverse of exponential function? Log x, logarithm, right? Logarithm. Logarithmic. Log e to the x. Maybe I'll change this to b instead as base. Okay, so again, what we usually use is log x instead. The graph look like this. You need to know what the graph look like, okay? Especially like if you want to use like limit later, take the limit as x goes to, let's say 0. You should know what is approaching to. So those graph you should know. Otherwise, how are you gonna do those? You know, right? Those for both 102 and 135, you should know what the graph look like. What is the domain? What is the range? Okay, for both 102 and 135. And another thing you should review is function transformation. I don't want to review that. It's something you should be familiar with. You do a lot of questions. Like find the range of all functions, something like that. You should know function transformation. I'm gonna skip that part. I'm gonna talk about combinations. So if you add functions together, you multiply them together, divide them, or you do function composition, how is it gonna affect the domain? Okay? For the first three, it's always you take their intersection. It's always you take their intersection. But the last one is slightly different. You need to care a bit more. Do I even have example for that? I don't think I do. But I should have an example. I'll give you an example later. I cannot think one right now, but function composition, the domain is gonna be different. You take x in domain of G, so x in domain of inside function, where the inside is in the domain of outside function. This is also important in 102, okay? That's why I will spend time, but I don't have an example later. Example will be posted later. I cannot think one right now, but I'll give you an example. Okay, let's look at 3. So do some function composition questions. So I have f, I have g, I have h. They ask you to find g compose f and h compose g compose f. You guys can do it? I'll give you 2 minutes. 2 minutes. Try it yourself. Anyone finish the first one? What's g compose f? What's your final answer? It should be easy to type. Okay, 2x, that's correct. Negative 2x? Negative 2x is wrong. Oh no. Oh, I was not expecting anyone to make a mistake. Okay, keep going. I'll quickly write down an answer for this one. Since most of you got it correctly, so you can keep going on this. I'll write the answer for this. Please don't make mistake. Those mistakes can cost you a lot of marks, guys. Because it's possible you cannot figure out how to do certain questions. So at least you want to make sure all the questions you know how to do, you can get them perfect. Okay, so at least you want to guarantee that. If you know how to do it, why would you lose mark, you know? So you see those two cancel out and this becomes plus. Okay, so it's log e to the 2x. Which is 2x. What about the other one? What did you guys get? Might be harder to type. 3 absolute value of x over 2x squared plus 1. That's correct. Okay. Anyone need me to take it up? Or you guys are good? This is a correct final answer. 2x squared plus 1. I can move on? Yeah? Nice. Okay, let's do 4. Take it up, please. Okay, fine. Let's take it up then. If you know how to do it, do 4, okay? The rest of you, if you don't need my help, then do 4. Just quickly do them. H compose G compose F of X. You need to do F first, so it's basically H of G of F of X. So h of g of, put f of x in there, that's gonna be 6 minus e to the 2x, right? And so the first part is basically the same as here, but I'm just doing it again to show you how it works. So that's h of g of x is ln 6 minus x. Oops, what am I doing? 6 minus 6 minus e to the 2x. So it's the same as before, right? And then this cancel out, so h of ln e to x, which is h of 2x, and you plug in 2x in h, that's gonna be 3 absolute value of 2x over 2x squared plus 2. Okay, but now you can factor 2 out. So this 2 can be taken out. 2 times 3 absolute value of x. Bottom, you can factor 1, 2 as well. So that's going to be 2 times 2x squared plus 1. Okay, so those 2 cancel out, and you'll be left with the final answer, which is this. Make sense? So you want to simplify it as much as possible. All right. Let's move on to 4. If you're down, type your answer in the chat. What happens to gx? Oh, I think I typed it wrong. My bad. I typed it wrong. Here should not include 1. Let me remove it. Sorry, guys. Here should not include this. I removed the equal sign here. That's why I did remove this equal sign here. Okay, 2 of you got the final answer. I'm waiting. Let's waiting for 2 more students type their answer, and then we'll take it up. I minus 2e to the power of 9 is correct. But we'll wait for another student. Anyone need more time? Should we clear? This clear? G of 1. Sorry, this is not supposed to be 1. It's supposed to be a bracket. So G of 1 When it's 1, it's this. So it's pi minus 2e to the power of -1. Bracket, bracket. Okay, so you figure out what is this. Is this, what is this? Is this less than or equal to 1? Is it in between 1 and 2? No calculator. So you can make some estimation, basically. You don't actually need to know the exact value. You just need to know which one do you need to use. Does that make sense? Okay? You don't need to know anything else. Just know which one should it be. Okay? It's greater than 2, that's correct. Okay, this should be greater than 2. This is 3 point something minus 2 over e, basically. 2 over e is quite small because e is 2 point something, right? It's bigger than 2. So this is bigger than 2, so it's gonna be 9. Okay, so here's -9, sorry. It's just gonna be g of -9. Even though I don't know the specific value of this, I just know it's bigger than 2. That's enough for me. Okay? And that's gonna be g of -9. So which one do I use? 1, 2, 3. Which piece do I use? The first piece, right?
1.
That's correct. So that's just pi minus 2e to the power of 9. The negative sign cancels out. Clear? Move on. 1-to-1 function. The definition is important for 102. Okay, this is important for 102. Not that important in 135. Because negative of -9 is 9. That's why. Make sense? As a 102 preview, guys, if this is a definition of one-to-one function, what is a contrapositive of this statement? Contrapositive. You guys remember what's contrapositive? That's correct. Okay, so remember this is equivalent to, oops, wrong pen. This is equivalent to if f(x1) equals to f of x2, then x1 equals to x2. Okay? And I'm telling you, those two are the ways to prove one-to-one in 102 and in 135. 135, they barely test you on proof, but this is 102 chapter 5. Okay, this is how we prove it. And we're nerding it now. Isn't that great? You are nerding it ahead of time. So if they ask you to prove the function is injective, in 102 we call it injective, this is what you do. You suppose f of x1 equals to f of x2, and you show that x1 equals to x2. Simple. Injective. This is a definition. The definition is this. So injective and one-to-one, they are the same thing. They're basically saying that you cannot have more than one x value mapped to the same y value. Does that make sense? So it's 1-to-1. 1x mapped to 1y. Make sense? 1x mapped to 1y. You cannot have 2x mapped to the same y. That's 2-to-1. You cannot have 3x mapped to the same y. That's 3-to-1. So 1-to-1 or injective means that 1-to-1. So 1x mapped to 1y. 3, 2, 1, go. That's what I mean. So what you guys really care about is actually horizontal line test. So they might give you a graph, for example. They might give you a random graph. Oh, and they ask you, oh, is this a 1-to-1 function? Does it have inverse? You know, something like that. And then you check, you do a horizontal line test, you draw a horizontal line. So for example, this, draw a horizontal line. It does not pass horizontal line test. Right, so it's not 1-to-1, it doesn't have inverse, but you can make it have inverse by restrict the domain. So under certain domain, so for example, this is basically 102 as well, okay? So let's do some 102 preview. This is x squared, y equal to x squared. This function with domain all the real number, it's not 1-to-1. You guys see it? It does not pass horizontal line test. Right, I draw a horizontal line, I have more than one intersection point. This is not 1-to-1. However, if I say, this is 102, okay? If I say f map from 0 to infinity to r via f of x equals to x squared, is it a 1-to-1 function now? Yes, right? Do you guys see it? So although generally speaking, under natural domain, it might not be a 1-to-1 function, but there are ways to make it 1-to-1 if you change the domain. Okay, so this part is important in 102. So you'll see that, well, it's the same expression. I give you different domain and codomain. The function can change. Okay, the function might be 1-to-1 in this case, might not be, it might be injective, but not surjective, it might be bijective, blah, blah, blah. So this is like 102 stuff. Okay, so but generally speaking, x squared is not a 1-to-1 function, so it does not have inverse. But if a function has inverse, okay, then you can have f inverse of x equals to y if and only if y is x. So basically you swap x and y. Swap x and y in f and f inverse. And the domain of f inverse is the range of s and vice versa. And you should know the cancellation equation. Be careful, you should not use this. This cannot be used, not on trig function. Not trig. Okay, this too, not on trig. Why? Because trig functions themselves, they are not 1-to-1 functions. So for example, sine function, sine, cosine, oh, this is not sine or cosine. Sine function, it's clearly not 1-to-1. It's because we restricted the domain to make it has inverse. But trig, like sine function itself is not 1-to-1 function. It doesn't have inverse. You cannot let it cancel with arcsine. It does not work like that, okay? Again, we'll do that in later, but that's something you should know. And also the graph of the inverse is symmetric to the original function with respect to y equals to x. It's something you should know as well. This I should write it down. So the domain, if f is from A to B, then f inverse, it will be from B to A. Okay, and the domain of this is A, of f is A, range is B, then f inverse is BA. Okay, again, in calculus, they basically consider the image of a function as a codomain. That's correct. If your function is after you do the restricted domain, then you cannot use it on the original function anymore. Okay. So for example, you should not cancel x squared with square root of x directly. right? If you do a cancellation, you end up with absolute value of x instead of x itself. It's not the same, right? So, let's do 5 as a practice, because you 100% should know how to find the inverse of a function. From practicing 102, you should know how to do it as well, because you know, find the image of a function in the second direction, you need to find the inverse, right? So, yeah, shall we take it up? Since one of you are done. Well, first of all, your first step is you write it as y equals to f of x, right? So, write it as y equals to f of x. Oops. F of x. And now, you can either swap xy first, or you can isolate x first. Doesn't matter. I'm gonna say isolate first because, well, that's how you do it in 102. I don't want you to mix them up, so let's do the same step first. So isolate x, write it as x equals to the function of y. Okay, and then you swap x and y. Just to be consistent with 102. Okay, so because of that, let's do it. Y equals to this ln 2x over 5 minus ln 2x. Okay, and then let's try to isolate x. So I'm gonna cross multiply. Hold on. Let me just do it directly. 5y minus ln 2xy equals to ln 2x. Okay? And then put the terms with x together, so 5y equals to ln 2x plus ln 2x y. And I can factor it out. That's gonna be ln 2x times 1 plus y. Right? So divide by 1 plus y. Make e to both sides, so exponent. And this is gonna be 2x divided by 2. So now I finish step 1 and 2, and then I can swap. So f inverse of x after you swap it, that's gonna be 1 over 2 e to the 5x over 1 plus x. That's the final answer. Any question? Question? You don't have to. You can swap at the beginning too. It's up to you. I told you I'm only doing 2 first, 3 next because in 102, I don't want you to swap them. I want you to isolate directly without the swapping. So if I ask you to swap first, I'm worried you'll do the same in 102 and you'll get the wrong answer. That's the only reason. Okay, remember in your rough work, you're doing this as well, right? So I want to be consistent with 102. That's why I ask you to do this first. But if you are more comfortable with swapping first, go ahead, okay? As long as you're not going to make the mistake in 102, you can go ahead, do whatever you're more comfortable with. Laws of exponent, this part, it's where I'm going to talk about common mistake. Yes, I'm talking about inversing image proof, the second direction of image proof. Remember the second direction of image proof, you need to isolate x. Find x equals to something something, show x is in the domain, plug it back in. Remember that part? I'm talking about that. Okay. Okay. Laws of exponent. My mistake. What is a common mistake? You should know all of those. The common mistake is people always separate them for some reason. Common mistake is people do this. Long x plus y equals to long x plus long y. No, you cannot do that, okay? But we see this every year. People always do this. You're still in here? You're still here? Okay. It's because this is 2 over e. E is 2 point something. It's bigger than 2. So the whole thing is smaller than 1. 3.14 something minus a number that's smaller than 1 is going to be bigger than 2. Make sense? Because it's bigger than 2, it's just going to be -9. Right? Okay, continue. Common mistake. Do not do that. Okay? And people, if I have changes to negative sign, people do that as well. I don't understand, but we see it all the time. This is the most common mistake people do. Don't do that. Those laws, you should know all of them by heart. Okay? Know all of them by heart. Number E, blah, blah, blah. This is easy stuff. I should not say easy stuff. It's not easy stuff, but you should be familiar with all of them from high school. Okay? That's why I want to skip them because they are high school material. High school materials. One thing I want to say is, I don't have an example here. One thing I want to say, if you're stuck at something like e to the power of e something something equals to something something, then you apply law on both sides. So because they're inverse of each other, they can cancel out, right? Apply law on both sides. If you're stuck, similarly, if you're stuck with long something, long blah 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 equals to the blah 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 blah, then you apply e on both sides. On both sides. E to some power of something. On both sides. Okay, I don't have example here, but maybe this is an example. Like for example, here we're pretty much stuck here. Like e to the 2x equals to this. There's nothing else you can do. That's why I applied e here. Okay, so similarly, if you're stuck with e to the power of something equals to something, there is nothing else you can do, and you apply law on both sides of the equation. Yes, you can do that too, of course. I just change it to the other one. It's up to you whichever one you want to use. They are the same thing. They're exactly the same thing. There is not much difference. But anyway, let's do this one. If A, B, C are positive real numbers such that long A is 5, long B is -1, long C is 10, what is the value of this? I want you to do it without looking at the laws above, okay? So you should do it without looking above to check your understanding. Okay, negative A is correct. Anyone need me to take it up, or you're all good? You're good, we can move on to trig, the fun part. Take it out? Okay, fine. Fine. I wanted to be lazy, but you guys are not letting me. Basically you use the laws, okay? B, C, okay. So it's a product. You can split it to sum, right? So that's ln of e to the 3 plus ln of a squared plus ln b plus ln c to the power of -2. And also you have power, and the power can be taken to the front, right? So let's use that. That's 3 ln e is just 1 plus 2 ln a plus ln b minus 2 ln c, and plug in the values. So that's 3 plus 10 plus -1 minus 20. Okay, and that's -8. That's it. It'll be a straightforward multiple choice question. Okay. You got the trick. Maybe we'll do one more question. Let me think. Yeah, we'll do 2, but I don't know time yet. I need to figure out my own schedule first. Yeah, though this will be recorded. Oh, this will be posted, yes. As practice, I mean, we're not gonna do it now, but as practice, I will give you some long and weak kind of questions. So practice. Let's do solve the following equations. A is ln x plus ln of x minus 1 equals to 1. B is e to the power of 2x minus 3 times e to the power of x plus 2 equals to 0. Okay, do them for homework. Okay. You guys done? Gonna move on? I'll post this, by the way, so don't need to copy anything. Definition of trig functions. You should remember they are the reciprocal. Reciprocal and inverse are not the same thing. Okay, because people keep thinking reciprocal and inverse are the same thing, but they are not the same thing. This is reciprocal, this is not the inverse. Okay, other than that, there's not much to say. When you evaluate the trig functions, you should always check the sign. Will be mainly tested on limits. I don't know. That's a question you should ask Maria, to be honest. I don't know. Her tests from the past few years are quite different. Like every year is the focus is different. So it's hard to guess, to be honest. Like last year, they barely had any trick at all. Last year, right, like last year, there was like only one trick and it was not even actually trick. But the year before, I think it was the year before, there were quite a lot of trig. And if you go back to a few years ago, there were some trig questions again. So I don't know. Okay, I don't know. I think she posted some for you on Quarkus. You should be able to see some. Yeah. Okay, so trig. What I want to say is, even though it might not be a big focus, you should check your formula sheet. Okay, so she posted a formula sheet for you, right? Did she? I suppose there is a formula sheet that she posted for you. You should check that. Okay, so you should check what is there or what is not there, right? So let's see. I think someone posted. So let me see what's there. You guys have all of those product formulas. Some you have this, you have this. You have this, you have this. Double angle. Where's my double angle? This. That's it. Okay, so she gave you half angles, product, addition formulas, and double angle. Those are those are the most important ones anyway. Okay, so the ones provided to you, you don't need to memorize anything. This one is barely used, so don't worry about this. Okay. But other than the ones she gave to you, you should know the basic stuff. Okay, so the basic stuff. This one, those two, this one, and this one. So those you should know them by heart, even though it's not provided to you. The basic stuff you should know, okay? Random derivative formulas. You guys didn't even do, you guys are not even a derivative yet, right? You're not even being tested. The one they gave to me, it has no derivative at all. The rest are on your formula sheet. Said they? Is that how? Or only, yeah, exactly. So the derivative part is useless for you. Because you're not even being tested on it. The rest of those are given to you on your formula sheet already. So I'm talking about the one that's not on formula sheet. You should at least know those. Okay? Yes, you'll be tested on derivative using limits. That's correct. That's gonna be part 2 stuff. We'll do that in part 2. Okay. So those, okay, remember you should know them. And the other thing is you should know Castro rule. Do you guys remember Castro rule? Yeah. Castro rule? It's used to check signs. So it's, you draw this. Oh, I don't remember it as cast. I use this like all students take calculus. All as often are positive, sine positive, tangent positive, cosine positive. Okay, so this is used to check the sign of your trig functions. All students take calculus, exactly. I don't call it Castro. This is how I memorize it, but you should know this, you should know those, and those are in the formula sheet. Inverse trig, of course, will be here. So if you should know the domain and range, this thing you should know. Okay, the graph, you should know this one specifically. This one is more important than the other ones. I don't even know why, but all calc professors like to test on this one. Again, I don't know why, but you should know this one. Okay, the other one's not as important. Let's do some simplification. Maybe we'll call it a day. Limits we'll do it next time. Okay. So this is what you guys were asking me. How do I do those? You should know how to do them. Okay. I'll give you some time to work on all 3 of them, and we'll take them out. Take us down. What is your final answer for 7? Sine x? Tangent x? Huh? I'm confused. Sine x squared over cosine x? No, I haven't seen a single correct answer. Oh, that's correct. X over square root of 1 minus x squared is correct. Oh no. Okay, I'm gonna oh no again. This is the correct answer. Let's write it down and then we'll take it out later. 1 minus x squared. What about 8? What did you guys get for 8? Three pi over 4. Negative pi over 4. Three pi over 4 is correct. No, Ali, no, that's not correct. 3 pi over 4 is correct. Okay, what about 9? Ugh, okay, so how do we do it? We need to draw a special triangle, guys. Special triangle. So, inverse sine x. Suppose this is theta. Then by definition of inverse, this is basically saying sine theta equals to x. Okay, except there is one more restriction because you need to check what is the domain, what is the range, right? So, this theta, or what should I say? What is my restriction here if I wanna switch to this? Anyone? Negative pi over 2 to pi over 2. What is negative pi over 2 to pi over 2? Is x or theta? Domain of inverse? Thus, domain of thus? Theta, that's correct, theta. Theta is in between negative pi over 2 to pi over 2. Okay? Not x, because this is a range of inverse trig. Range is what theta can be, not what x can be. Okay? Make sense? Okay. That's okay. Now you can draw a special triangle. In this case, it doesn't really matter. But suppose, it's terrible. Suppose I draw a special triangle. Okay. Let's call this theta. Then sine theta is x. X is basically x over 1. You can make a special triangle. For example, this is x, this is 1. Then sine theta is gonna be x, right? Then what's this part gonna be? Square root of, let's go square root of 1 minus x squared. Okay? And now, tangent of this, which is tangent theta. So what's tangent theta? Is what? Maybe I'll write it. Tangent sine inverse x. It's basically tangent theta. And what does it equal to? In this triangle, What's tangent theta? X over that. Okay, but we're not done yet, okay? X over 1 minus x squared. Where is this coming from? Because I know sine theta is x, so I can create a special triangle. No, it's not always. It's just a way to do it. Not always. Don't try to generalize a specific way that works for everything. That's not how it works. Like a lot of time it works, but it's not like always. You should not say always we do this. Sometimes you might need to use trig identities. You know. But does this make sense? Where my tangent is this over this, right? So this over this is x over this. We'll do all of them, okay? Does 7 make sense? Let's do 8. 8 and 9, you'll see there is a specific value here, so you need to check the sign, okay? Because the specific value will give you more information. Now, it's the same. We can let this be theta, for example, or x, or whatever, it doesn't matter. Let this be theta, okay? Then, what is my restriction for theta? Restriction means when you should check what my cosine inverse can be. The range of cosine inverse is what? What's my restriction, guys? It's from 0 to pi, right? It's from 0 to pi. This is why negative pi over 4 is the incorrect answer. Okay, because this can never be negative. You can only get value from 0 to pi. All other answers are incorrect. Make sense? That makes sense? Because the range of this is 0 to pi. Okay, you cannot get negative numbers. It's impossible. All right, so if you know that, we can draw a special angle again. In this case, it works. So let's call this theta. Okay, then this if and only if cosine theta equals to negative 1 over square root of 2, right? This is by definition of inverse. Definition of inverse, remember? If f of A equals to B, if and only if f inverse of B equals to A, you swap them. Right, so f inverse of B equals to A if and only if f of A equals to B. With restriction thus. Okay. Now, oh, I don't even need a special triangle here. You know? Why? Because well, you just need to think what theta can make it work. You don't need a special triangle here. Special triangle is not needed. So what theta can make cosine be negative 1 over 2, square root of 2? Are we given the chart? No, we're not. You need to know it by heart. What is this? This is negative root 2 over 2. You don't know this? Okay, what about this? Do you know which x would make it square root of 2 over 2? What about this? Do you know this? Pi over 4. That's correct. Okay. If you know that, then you can do this. It's the same. We know that when let's just write this. We know that cosine pi over 4 will give us root 2 over 2. But here I need negative, right? I need negative of it. Right? So we can draw this. Pi over 4 is around here. This is pi over 4. Okay? But I need it to be 0 to pi. So it's somewhere here. And I also need it to be negative. Remember, all students take calculus. In this, it's positive. So I need it to be here. So which angle in here will be the same value, absolute value will be the same with this. It's when you draw the same thing. Okay, so it's when you are pi over 4 away from pi. When you are pi over 4 away from pi, they have the same value, just different sign. So because of this, we know that theta is 3 pi over 4. Why? So it's just pi, yeah, it's just pi minus pi over 4. Why? Do you guys remember for unit circle? How do you calculate sine, cosine? Do you guys remember? So for example, I have a point here, you know, do you guys remember how to calculate sine, cosine? It depends on a lot, depends on your x and y coordinates, right? Do you guys remember? It depends on your x and y coordinates, right? And because of that, you'll see that, well, at here or here, if you ignore the sign, of x, y coordinates, they have the same x and y coordinates, just the sign is different. Do you guys agree? Right? Because of that, the cosine will be the same because the xy coordinate is just the sine and cosine of the angle. Do you get it? Make sense? Does this make sense? Because your x and y coordinate just sine this angle and cosine this angle. And the only difference is the sign difference. Just like the x will be the same, but y is a negative of it. That's why. Okay, so ignore the sign, they should have the same, the absolute value will be the same. Similarly, this angle would have the same one too. So this angle, let's draw it here, like this angle. You'll see that, well, this angle will have the same x and y coordinate if you ignore the sign again. Okay, so the y coordinate is the opposite of this, x is the same with this one, and similarly, this angle will be the same as well. Do you guys see it? That is y. Okay, so if you know this, you should be able to figure out the rest. It's just adding a negative sign. When you know which coordinate it's in, so we know that it has to be here, so it must be this angle. Does this make sense using the unit circle? Okay, so those angles, this one, this one, this one, this one, ignore the sign, they will have the same value, but you need to determine the sign based on cast rule. Make sense? Okay, move on next. Tangent inverse 5 over 12. So again, let this be theta. What's my theta? What's the restriction for theta? It has to be in between. Oops, not this bracket. Theta is in between negative pi over 2 to pi over 2. So you change it back to tangent. So tangent theta is 5 over 12. Okay. Special triangle. Theta, 5 over 12. 5 over 12. Right? So what is this? 13. Okay? Also, you need to determine the sign as well, okay, just in case. So draw the casserole sign thing. Okay? Thus, draw it on the line will be here. And you write down the casserole here. So all students take calculus. My tangent is positive. Positive means that, well, it can only be here, right? If it's here, it's negative, so it's only here. Here is all, so everything is positive. So you don't need to worry about sign anymore. So sine tangent inverse of 5 over 12 is sine, we already know, it's sine theta. What's sine theta? Pi over 13. Do I need to add negative sign there? Yes or no? No, why? Because in here, okay, that's correct, because we're here. Here, everything is positive. Make sense? So again, if you're given specific value here, you need to be more careful with the sign. Okay, you need to draw the casserole diagram and determine the sign. If you are not given that, then the sign does not matter anymore, because this can be positive, can be negative. We don't know. Okay, so it depends. But if you are given specific value here, you need to be extra careful with the sign and always know what is the range. You know, those are easy to make mistakes. Does this make sense? It's not purely, so two things are affecting the casserole, which quadrant we have. First thing is your range. So the first thing you should draw on the casserole is a range you have. So you have, can only be here. The second thing is you look at the cosine theta. The cosine theta is negative. Okay, so from those two, you pick the one that's negative for cosine. So only here it's negative. Make sense? So that's how we determine for this one. For this one is a range, which is here, which is a pink part. And also I know my tangent is positive. Okay? If I pick here, tangent will be negative. So it's not here, which means I can only pick here. Does that make sense? Yeah, 13 is from Pythagorean theorem. That's correct. Make sense? Whoever asked me? Stand for anything? Yeah, of course. A means all. Did you guys not know this? I'm kind of concerned now. This is from high school, guys. All are greater than 0. S means sine greater than 0. T is tangent. C is cosine. Okay? So means that here in this quadrant, only sine x is greater than 0. Tangent and cosine will be less than 0. This means only tangent is greater than 0. Sine and cosine will be less than 0. That means cosine x is greater than 0. Sine and tangent are less than 0. Does that make sense? So each of the letters, they stand for something. does this make sense? Gabriel? Okay, so because of that, and I know tangent has to be greater than 0, right? So if I pick here, it's gonna be less than 0, so I can only pick the all part, the A part. Okay, you should know this, and I'm running out of time, but limits is really important. Should I do a little bit? We decided positive. No, you decided positive or negative based on this to pick a quadrant and decide if this is positive or negative based on which one you are in. Memorize? You should not memorize anything. You can calculate it yourself. Yeah, you convert it. So let's say it was negative 5/13. Which one? If I change this to negative, this value depends on which one you are. This value depends on which one you pick. Okay, so if tangent is negative 5/12, then you need to pick this one. Okay, and in this quadrant, sign is negative, so you would have a negative sign here. Does that make sense? This one decide which one you pick, and this depends on which one you have. I'm glad I did the review, otherwise there are so many things you didn't know. That's really concerning, you know. Why does cosine have to be because it's all. A stands for all. It means that all of them are positive. A is all. Does that make sense? How did we know it's all instead of 10 being positive? Oh, we have this from the beginning, so it cannot be here or here already. You can only pick either this or this because of the range. Yeah, because theta is from negative pi over 2 to pi over 2. So you cannot pick those two from the very beginning. From the very beginning, from the range, you can only pick one of those two. Okay? And because of that, I know well, this is positive. So I get rid of this, so you can only pick this one. That is why. Domain. Yeah, this is the range of this, which became the restricted domain of this. But the domain of tangent x itself is not this, okay? It's the restricted domain of tangent x when it has inverse. Okay? Because this theta and this theta is the same thing. That's why I only need to write it once. So if tangent is negative 5/2, then cosine. No. If this is negative, then this becomes negative 2. Because if it's negative, then you need to pick this one instead. And sine theta in this quadrant is also negative. Oh, you're talking about cosine. Yeah, cosine will be positive. That's correct. Yeah, cosine will be positive. That's correct. The triangle will be the same, okay? The triangle will be the same. The difference is which quadrant you're gonna pick. You can always use positive number for the triangles. It's just a different quadrant you're gonna pick here. But cosine is gonna be positive, that's correct. Okay, so Limits, I don't have time to do that. I want to give you a summary so you can do some of the question yourself before I do part 2. Like those questions, you can try them yourself. Let me quickly give you a summary and we'll call it the end of the day. Those we'll go over in part 2. But before part 2, I will summarize something. We'll do that next time. But I want to give you something so you can start doing something. A brief summary here. If they asked you to compute the limit, and you know fx is given, the expression is given. Okay, this is under the review will be rest of the materials. If you're giving the expression, they ask you to compute the limit, your first step is always simplify it. So it's a flow chart. Simplify. Okay, after you simplify, you plug in numbers. Plug in A, you will have different result. One of the result is you'll have A over B, where A, B are not 0. I mean, B is not 0. A can be 0. If you get this, done. A over B is your final. This is your final. We're done. If you plug in your A and you got something like C over 0, where C is not 0. So it's not 0 over 0, just something over 0. Okay? Then you need to discuss one-sided limit. Okay, so check one-sided limit. Oops, I should write it here. And if it's positive infinity, you'll get either positive or negative infinity. For your one-sided limit. If they are different, then obviously limit does not exist. Left-hand side limit does not equal to right-hand side limit. Then limit does not exist. Okay, but if they're equal, you'll either get this or this. The third case is you have 0 over 0. Zero over 0. What do you do? You multiply by conjugate. Okay, and then simplify. This is most time would work, not all time. Okay, simplify and repeat. Repeat what we have there. Okay. The detail we'll do it next time. Now it's just a brief summary that you can get started. Okay. But detail every other question I will do it next time. Now it's just a brief summary. Now there is one more case. If we have bounded function in f of x, Bounded function, remember what's bounded function? Bounded above and below. For example, sine x, cosine x. Arctan x. Those are bounded function. Then it's use squeeze theorem. Okay. Detail we'll talk about next time, but this is a brief summary of how do you do limit questions. It can get you solve most of the questions you'll see in 135. Most, not all, of course. Okay. I'm gonna end here because I'm over like 43 minutes over the original planned time. So we're gonna stop here unless anyone has any question. Not about limit, because limit will do it next time, but from before, if you have any question.